So welcome back. Our new topic is calculation of area. Calculation of area. And how do we calculate area? Area in surveying means land area mainly. How do we calculate an area of a plot of which in its a building is constructing? How do we calculate an area of a panchayat? How do we calculate an area of a taluk? How do we calculate an area of a district? Okay, it can go further and further. Okay, and right now we have many advanced methods of calculating area, but we are sticking on to the basic methods. How do we calculate area? Using pen and paper calculations after measuring all the sides or after measuring by manually. Okay, so the primary method we use for calculation of area by surveying of a land was by triangles. Triangles. Okay, suppose if this was the area of land, you will divide this area into a number of triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right now 9 triangles. Okay, so then we will find out areas individually. Okay, we know how to find areas of triangles, like area is equal to root of s into s minus a, s minus b, s minus c, where s is a plus b plus c divided by 2. Okay, and we have many other methods like this. Okay, so this is one method to calculate areas. Right now in this class we are concentrating on a different type of area measurement or different type of calculation of area using as a special case. Okay, this one is called area calculation, areas from offsets to a baseline. Okay, offsets to a baseline means there will be a baseline like this. Most probably it will be a chain line. Okay, baseline, and the measurements will be taken as offsets. O1, O2, O3, O4, O5, etc. Okay, etc. On. Offsets to a baseline. These are offsets. This is the baseline. Okay, and we have to find out this area. This shaded area is the area in question. Okay, and in this class we are talking about areas from offsets to a baseline as a special case with equal intervals. Equal intervals means all these measurements will be equal. If it is 10 meters, 10 meters always. If it is 15 meters, 15 meters always. Okay, so this value will always be a equal value d. Okay, with equal intervals. Okay, so primarily we have 4 methods, and 4 methods are: first one, mid-ordinate method. Second one, average ordinate method. Third one, trapezoidal method. and last one Simpson's method. There are four methods primarily used to find areas from offsets to a baseline if it is equal intervals. Okay, so we are getting into first one. Okay, in this one there is a slight change of measuring offset with respect to all the three other methods. Okay, only in first method, only in mid-ordinate method there is a special concern of changing or taking offsets. All other three methods will be another method. Okay, in this mid-ordinate method, if this is the baseline and this is the equal distance d, okay, the offsets will be taken from the middle of ordinates. If it is 0, 1, 2, 3, 4, 5, offsets will be taken from middle of ordinates. First one, we will be taking offset O1. Second one, from the second division, they will be taking O2. Third one, O3. Fourth one, O4. Fifth one, O5. Okay, so now you have to find out this area. Okay, so in mid-ordinate method, as the name indicates, ordinate will be at the midpoint of each divisions. Mid-ordinate method, O1, O2, O3, O4, O5. Okay, so the equation is so simple. We will be taking the average of all the ordinates and multiply with the total length. That's it, obviously. So average ordinate is area O1 plus O2 plus O3 plus etc. O n, where n is number of divisions. Number of divisions. D is interval. O1, O2, O3, etc. ordinates. Okay, so O1 to On divided by, there is n values, 1, 2, 3, 4, 5, etc. n. So n, we are taking average multiplied with L, and obviously L will be equal to n into D, as it is equal ordinates. 1, 2, 3, 4, 5 into D, that will be total length. Okay, so sigma O by n into n d, that is d sigma O. That is how we find out area using mid-ordinate method. So moving on to next method. The diagram will be little bit different. Okay, the diagram will be second one, average ordinate method. If this is the baseline with D, L being from here to here, total length. This is the point. In the remaining methods, all the three methods, average ordinate method, trapezoidal method and Simpson's method, this will be the diagram. The ordinates will not be taken at the midpoint, it will be taken at end points of all divisions in here. and it will be named as O0. In here, next one O1. Okay. Previously it was in the midpoint. Now we will be taking ordinates at the end points. Okay. O0, O1, O2, O3, O4, etc. On. Okay. So this is the type of ordinates taken in all the remaining methods, and this remaining methods including 2, 3, 4 methods will be asked most frequently than mid-ordinate method. Okay, so in average ordinate method, again we will be calculating by the same criteria, area that is equal to O0 plus O1 plus O2 plus O3 plus etc. plus On divided by, in previous case there were n values, but in this case there is 1, 2, 3, 4, 5 or n plus 1. There is O0. Okay, so n plus 1 into capital N or n into d. Okay, so in this case it is n by n plus 1 d into sigma O. Okay, I hope it's clear. Next one, third method. Trapezoidal method. Trapezoidal method. In this method, we are assuming that all the divisions are trapezoids. All these are individual trapezoids. Okay, and we are calculating the area of total offset between the baseline, offset and baseline using addition of each of such trapezoids. Okay, we are trying to derive its value. Okay, so now we will be taking first one, for example. Okay, so taking O1, O0, O1, D as a single trapezoid, the area will be O0 plus O1, delta 1 is equal to O0 plus O1 average into 2 divided by 2 into D. That's it. Okay, delta 2, second one, O1 plus O2 divided by 2 into D. Okay, so hence it goes. Third one will be O2 plus O3 divided by 2 into D, etc. Okay, so when we add all these things, okay, add all the ones together, we will be getting delta is equal to O0 plus On divided by 2, that is the first one and the last one, end ordinates, O0 plus On divided by 2 plus O1 plus O2 plus O3 plus etc. plus On minus 1 into D. That's it. Okay, so the theory behind that one is O1 will be repeating and the next one O2 will be repeating. So there will be one singular ones and there will be only one end ordinates. At the end O1 will stand out, On will be standing out, at the beginning O0 is standing out. So we are taking by 2 inside it and D into average of end ordinates O0 plus On divided by 2 plus the remaining intermediate ordinates. Okay, so understand by that concept, take the average of end ordinates and add it with all the remaining intermediate ordinates, then multiply it with interval. That's it. So that is trapezoidal method. Last one, And the most important one, Simpson's method. Simpson's method. In Simpson's method, we will not be considering it as a single unit. Okay, in all the previous methods, we consider it as a single one. But in Simpson's method, we will be taking two divisions together like this. We will be calculating these two together. And in Simpson's method, it is assumed as this line is joined as a parabolic line. And Simpson's method is proved to be more accurate than any of the methods. Okay, that's why we found out Simpson's method, and it came at the last. So it will be considered as two divisions together, and it is assumed to be joined by a parabolic line through offsets. Okay, and if we take that equation D, and if suppose this is the ordinates O0, O1, O2. To solve this, I will connect this with a straight line and consider this portion as a trapezoid, and this remaining portion will be taken as a parallelogram and 2/3 of this parallelogram. Okay, I am going a little bit fast because you may not be asked to derive this equation. Okay, so as a result, the equation will be delta is equal to d/3. After all the equations solved, after summing all the values, d/3 into O0 plus On plus 4 into O1 plus O2, O1 plus O3 plus O5 plus etc. On minus 1 plus 2 into O2 plus O4 plus etc. O n minus 2. This is the final equation. And understand it by theory. d/3, 1/3 of interval plus end ordinates O0 and On plus multiplied with 4 or 4 times the even ordinates. Even ordinates means second one, fourth one, sixth one, etc. Even ordinates plus 2 into odd ordinates. Okay, that's how we find area using Simpson's method. Okay. So if you get it, d/3 into end ordinates, adding end ordinates with 4 times even ordinates. Even means 1, 2, O1, 3, 4, O3, 5, 6, O5. Okay, even ordinates plus 2 times odd ordinates. Odd one, third one, fifth one, seventh one, etc. Okay, that is how we find area using Simpson's method. Okay, so that is the 4 methods to find areas from offsets to a baseline where intervals are equal. Okay, now we will do a problem. So this is the values and this is how you draw it. This is the baseline with 15 meters. 15 meter as equal interval. Okay, and the readings are 0, 2.67, 3.8, 3.75, etc. till 5.85. Okay, and we need to find out the line joining all these lines and the baseline. Okay, so first method to be used is average ordinate method. Okay, that is delta is equal to nd by n plus 1 into sigma O. That is, n in here is, we'll establish that n is equal to, after drawing it you can find out, you can find the value, or counting just the values you can find out the n. N in here is 1, number of divisions, that is 1, 2, 3, 4, 5, 6, 7. N is 7. D is, as given in the question, 15 meters. Okay, so N 7 into 15 plus 7 plus 1 into 0 plus 2.65 plus 3.80 plus 3.75 plus 4.65 plus 3.6 plus 4.95 plus 5.85. That's it. You find the answer for that. Answer is 383.91 meter square. Okay. Second one, or this was A, B, trapezoidal method. The equation was area is equal to D into end ordinates. End ordinates are D into sum of end ordinates. End ordinates are 0 and 5.85. 0 plus 5.85. I write the equation first. Okay, 0 D into O0 plus On plus divided by 2 plus O1 plus O2 plus etc. On minus 1. Okay, so that is D into O0 is 0 plus On is 5.85 divided by 2 plus the rest of the values, 2.65 plus 3.8 plus 3.75 plus 4.65 plus 3.6 plus 4.95, and D is 50. 394.87 meter square. Okay, the value will be varied, but it's all in the same range. The difference is about 10 meter squares. This applies, and we take trapezoidal as more accurate than average ordinate method, and we take the last method, Simpson's method, as the more accurate than all three methods. Okay, so the last one, in Simpson's method there is a light twist, because Simpson's method is applied, as we know, it is applied as taken by pairs. We will be taking 2, then again 2, then again 2. But in this case, the number of divisions is 7. 1, 2, 3, 4, 5, 6, 7. There is odd number of divisions. Okay, so you cannot directly take the whole 7 odd number of divisions into this equation. Okay, so we need to take even numbers always, not odd numbers. So we will be taking, right now we will be taking this one till this only, okay, and this one we will be calculating by trapezoidal formula. And adding with Simpson's formula. So from O0 to O6 we will be taking Simpson's method or Simpson's equation, using Simpson's equation, and the last one only we will be taking by trapezoidal formula, and adding these two we will get the final answer using Simpson's method. Okay, I hope you get it. In Simpson's method we only take even number of divisions. In this we have odd number of divisions. So we take, right now as it is 7 divisions altogether, we will take the first 6 as Simpson's equations, and the last one we will be calculating by trapezoidal formula and adding with the Simpson's equation. Okay, so Simpson's equation, delta is equal to d by 3. First one, O0 plus O6, 1, 2, 3, 4, 5, 6. O6 plus 4 into O1 plus O3 plus O5 plus 2 into O2 plus O4. That's it. Substitute the values. 15 by 3. O0 is 0. O6 is 4.95 plus 4 into O1 is 2.65 plus O3 is 3.75 plus O5 is 3.6 plus 2 into O2 is 3.8 plus O4 is 4.65. Okay, and the final value is 309.25 meters square. That is still O0 to O6. The one is remaining, and the last one delta, and this was 1 to 6, and delta 7 is equal to, by trapezoidal formula, that is 4.95 plus 5.85 divided by 2, basic equation, into 15d. It has been given derivation. Okay, that will be given as 81 meter squares. Okay, and the final answer, delta is equal to delta 126 plus delta 7, that is 309.25 plus 81, that is 390.25 meter square. So that is how we found out area of this offset and baseline using 3 methods: average ordinate method, trapezoidal method, and Simpson's method. Simpson's method has a little bit of a twist, and we found the last one by trapezoidal formula and added with the remaining, because while using Simpson's method we will be taking only even numbers, 1, 2, 3. Okay, thank you.